They're sleek, they're fast, and they're fun. Fiberglass boats can jump waves and turn on a dime. The fiberglass body is low maintenance and durable, so these watercraft don't deteriorate the way wooden boats can. A computerized saw cuts out the wood pieces they'll use to build the mold for the fiberglass boat. It takes a team of artisans about 15 months to design and build the mold. They first construct the frame. Then they construct the shape out of fiberglass. The mold must be perfect in order to cast a boat that's free of faults and defects. So they painstakingly work on the mold's finish, in particular, coating it in a special high-resistance paint that will withstand about 8 years of castings. Once they've finished the mold, they can begin casting the fiberglass boat. The equipment feeds just the right ratio of fiberglass to plastic resin. Fiberglass is glass in the form of very fine, flexible fibers. They may look fragile, but those fibers are stronger than steel. And they won't burn, stretch, or rot, so they make the perfect boat building material. Workers make sure they roll the fiberglass into every nook and cranny. This is critical, because if they don't apply the fiberglass thoroughly, the boat will have structural defects. As heat within the fiberglass builds up, it hardens. Next, they roll on a material called roving. It reinforces the fiberglass and makes it more rigid. They also install wood in the areas where they'll later mount equipment. They coat the wood with fiberglass to protect it from moisture. After about an hour, it's time to extract the casting from the mold. They use a lever system to lift out the hull. They cut out holes for the mechanics. Then they install the boat's deck. They install the motor and the electrical wiring for the mechanics and plumbing. The boat truly takes shape in the final assembly. They put together the upper part of the boat, called the shell, and the inside, called the liner. They install the furniture. Certain components are installed by hand, such as the dashboard. Last stop, quality control. A series of tests to ensure that all the mechanics function well and that the boat is absolutely watertight. Finally, a wrapping is added to protect the boat during shipping.
Boat propellers were invented in the early 19th century, and they've been making waves ever since. These propellers rotate in a screw-like fashion, drawing water in and pushing it out to move the boat across the water. With a steel propeller, you can zip across the lake in a flash and make a real splash. Production begins with wax pellets which are melted until they're the consistency of toothpaste. Nearby, a mold of a boat propeller closes and the thick wax is injected into it. It takes about a minute for the wax to cool into the propeller shape, which will serve as a pattern for the metal prop. A shot of compressed air helps extract a wax funnel from its mold. It's called the pour cup. We'll find out what's poured into it later on. After a cast shape is wiped down, its flat end is softened on a burner and joined to the glue-coated end of the pour cup. Workers dip the attached pieces into hot wax to fill any gaps in the joint. A quick wash and rinse gets rid of any oily residues left behind. Here, a robot submerges a rack of propellers in a special solution that gives them a non-stick coating. Then, it's over to a tank containing a mix of silica sand and water. The robot dips the wax propellers several times, then plunges them into various ceramic-based concoctions. After each dipping, the propellers go into a machine that showers them with sand. Then they dry under fans. The process of dipping and sandbathing builds up a hard ceramic shell around the wax. Workers load the propellers into a pressurized oven called an autoclave where the wax melts away, leaving only the ceramic shells. Those shells are then fired in big ovens, the way potters bake ceramics to strengthen them. Nearby, molten steel is bubbling, heated to the melting point by electrical induction coils. A worker takes a ceramic propeller shell out of the oven. Then the searing steel is poured into it through the pour cup. The steel immediately begins to cool, causing cracks in the ceramic shell. Any remaining bits of ceramic are knocked off with a metal rod. Now, it's time to get rid of the pour cup, which has already served its purpose. They grind the edges to smooth them. Then a more intensive grinding removes any corrosion on the surface. Talk about putting your shoulder to the grindstone. This process takes skill and strength. The propellers are lowered into a series of vibrating polishers. The friction from these pulsating cones smooths out the grind lines on the propellers and adds shine. Finally, each propeller gets the once-over from a laser that measures the blades from all angles. It sends the information to a computer, which compares it to the specifications. If it checks out, the propeller will be on its way to a waterway, ready to launch.
A paddle boat is a small recreational vessel, perfect for a leisurely ride on a lake. It gets its name from the rotating paddle wheel that propels it. You simply sit in the seat and turn the paddle wheel by pedaling, which is why this type of boat is also called a pedal boat or pedalo. Steered by rudder and gliding on two floaters, a paddle boat delivers a smooth, relaxing ride. Boat mechanics don't get much simpler than this. In a typical two-seater, 2 sets of pedals, each powering a paddle wheel at the rear. The factory molds the top and bottom halves of each floater separately. First, workers spray the mold with gel coat, a type of polyester. This is the floater's surface finish. Next, they cover the entire mold with fiberglass cloth. Then add a second layer in the front and bottom, where the floater will be a bit thicker. Then they lower a cover onto the mold, latching it down securely to make the mold airtight. They draw a vacuum to extract the air trapped inside. Then inject liquid resin. The resin saturates the fiberglass cloth and within an hour hardens, producing solid fiberglass, a lightweight material that's both impact resistant and waterproof. After extracting this half, workers mold the other half of this floater and the 2 halves that make up the other one. Then they apply fiberglass glue to the edges and carefully align and mate top and bottom. They position spacers to put pressure on the base of the groove, then clamp the perimeter for about 45 minutes until the glue sets. When the glue is completely dry, they trim the perimeter to make the edge neat and smooth. To make each propulsion wheel, workers rivet 8 blades to a fiberglass hub. These strong plastic blades do have some flex in them. This ensures they won't break should the wheel hit a rock or other obstacle. The part of the boat where you sit and pedal is called the bicycle. The 2 bike bodies, like the floaters, are made of molded fiberglass, then jazzed up with decals. Since the bicycle mechanics are routinely exposed to water, they must be rust-resistant. Therefore, the pedal mechanism is made of chrome-plated steel, and the chains of steel that's been treated with an anti-corrosion coating. Each bike has 2 chains, the first linking the pedals to one side of a central gear, the second linking the other side of the central gear to the propulsion wheel. So once they're both hooked up, pedaling moves the first chain, which rotates the gear, which moves the second chain, which turns the wheel. Final assembly is relatively simple. First, workers connect the floaters with 3 painted aluminum crossbars. The paint is baked on to make it extra durable. Then, on one of the crossbars, they install a pair of aluminum rudders, the boat steering mechanism. They link the rudders with an aluminum bar so that they move in unison. A hitch pin locks the bar securely in place, while this rubber cap prevents paint chipping when the rudders hit the crossbar. After mounting the first bicycle, workers install a console in the center of the boat. It contains a waterproof storage compartment and the handle which directs the rudders. It connects to the rudders with a long bar called a tiller. Next, they mount the second bike. Like the first one, it's designed to snap securely onto the crossbars. The adjustable fiberglass seats slide onto aluminum rails. The seats have fixed cushions in rugged waterproof fabric. The boat's retractable canopy is made of the same fabric on an aluminum structure. A paddle boat is virtually maintenance-free. You just have to oil the mechanisms a couple of times per season. And from then on, it's smooth sailing.
The first yachts were simple, sturdy vessels used to take explorers on voyages of discovery. Today's yachts are floating vacation homes. Equipped with every convenience, the luxuries increase with the scale of the vessel. Modern yachts are the ultimate way to explore the coastline. If you can afford one of these, you're living the dream. This motor yacht offers all the comforts of home on the water. Making this mid-sized yacht starts with a mold for the hull. The team sprays a gel coat paint onto the entire inner surface of the mold. This paint will transfer to the hull during molding. They layer fiberglass strips around a PVC foam core and create a series of distribution channels for resin. The crew now drapes an enormous sheet of clear plastic over the materials in the mold and seals the edges with tape. They leave a lot of slack in the plastic to conform to the mold's deep recesses. A vacuum hose suctions out the air beneath the plastic. The crew then connects plastic tubing to the ports in the distribution channels. All this plastic tubing leads to one place, the vacuum pump. The vacuum pulls resin through the network of tubing, into the ports, and through the distribution channels. The resin saturates the fiberglass strips that surround the PVC foam core. The vacuum sucks the layers into a tight sandwich and pulls out more air and excess resin. A worker pulls the plastic away from dry spots so the resin flows into these areas. The resin cures and the fiberglass layers harden. The next day, the team removes the plastic sheet from the molded part. They pull off the resin distribution channels and the ports. A crane lifts the newly molded hull out of the mold. The gel coat has adhered to it, giving it a glossy finish. The crane transfers the hull to a wooden cradle. From this angle, you can see the molded inserts for the propellers at the back. Next, they create the yacht's deck. They cover some areas of the mold in plastic to protect them from the first gel coat in a two-toned paint job. After the first color goes on, they gel coat the areas that had been covered in plastic. This two-toned paint job is done for aesthetic reasons, but it also color codes the areas that have a non-skid texture. Like the hull, they make the deck mainly from fiberglass. A worker cuts out the strips in different sizes. The fabrics have various thicknesses and weaves, all geared to the deck's structural requirements. He numbers the pieces to designate their placement in the mold, and he stacks them sequentially. After arranging some of the fiberglass strips in the mold, they build up the deck in certain areas using pieces of balsa wood. Balsa wood is extremely lightweight, but it will add strength when laminated into the fiberglass sandwich. The strategic placement of the balsa wood in high-traffic areas creates a solid core that will hold up to heavy use. A worker lays more fiberglass strips, encapsulating the balsa wood. They'll laminate the layers with resin, the way they did with the hull. They also make the roof structure the same way. Here's a side view of the cured fiberglass sandwich. A boat builder applies putty to the fiberglass to even out any irregularities. And after grinding the hardened putty smooth, they spread polishing compound on all the yacht body parts. They buff the fiberglass until the glossy surface gleams even more. Using a router, the crew cuts out holes for lights, portholes, and other features. An inspector taps the fiberglass to check for air voids that would compromise the yacht's structural integrity. He confirms that everything is shipshape. Production now moves to the yacht's interior. With the bulkheads now in place, the hull is ready for furnishings and fittings. A computerized router cuts American cherry wood to a set of exact measurements. This particular piece will be part of a storage locker. At another station, a craftsman glues a dozen cherry strips together for a valance. These laminated strips will be easier to bend to the desired shape than a thick board. He wraps them in wax paper to prevent the glue from seeping out during bending. The team places the laminated strips between the two parts of a bending jig. They clamp the jig to close it tightly. The adhesive sets overnight, and the wood hardens to the curved shape of the bending jig. The woodworker now clamps the valance to the workbench to steady it as he trims the edges. He positions a template on the valance and follows it with a router to cut out a hole for an air conditioning vent. Yes, the yacht will be equipped with air conditioning. He inserts the custom wooden vent in the hole. Turning now to the salon's coffee table. A router cuts holes in the cherry wood while bristles keep the dust down. A worker applies glue and inserts pieces of maple into the cutouts. He lightly hammers the pieces to drive them further into the holes. Then it's into an automated sander. It sands the inlaid wood flush to the cherry tabletop. A crew now brushes varnish onto all the wood pieces. The varnish enhances the wood grain and it protects the surface. After the varnish dries, another worker polishes the wood to a high sheen. Another worker then screws pedestal hardware into the back of each table to prepare them for installation in the yacht. The hull has been equipped with the 2 diesel engines at the back. A worker now assembles the clothing locker in the guest's stateroom. And in the master stateroom, construction on the ensuite bathroom is underway. The worker screws the toilet in place and connects the water and waste hoses. They rough in a utility room for a washer and dryer at the back of the yacht, next to the mechanical systems. They situate the propellers in the molded niches in the bottom of the hull, and the technician connects them to swiveling mechanisms called pods. He hooks up a pump that will replace lubricating oil when needed, so there'll be no need to pull into port for oil changes. He installs intake systems that will suction lake or ocean water into the hull to cool the diesel engines. Other mechanics include the air conditioning system, water heater, and a generator. And now, the big moment. Using a crane, they lower the yacht's deck and pilot house onto the hull. This deck assembly weighs 3 tons. Looks like it's a good fit. Using crowbars, the team pulls the flange of the deck over the hull. They drill threaded holes through the fiberglass flange and the hull and screw bolts into those holes to connect the two. Special adhesive has been applied to these bolts to keep water from penetrating the vessel. Here's the view inside. The cherry paneling in the pilot house seamlessly matches the paneling in the living quarters. The builders complete the furnishings, giving the cabin the look and feel of luxury. They install a high-end galley kitchen, and this yacht is complete. After 6 months of work, let the good times begin. Radar helps boaters find their way through fog, darkness, or stormy weather, ensuring they aren't operating blind. Special pedestal mounts elevate these radar systems to extend the antenna's range. The mounts also provide stability for the equipment in rough waters, so it's steady the course. Boat radar mounts are one of the most important things on deck. They support critical navigation equipment. If it was lost, the boat could be lost too. A radar mount starts with computer drawings that detail the geometry. The drawings specify the height and angle of the tower. The parts are made from extruded marine-grade aluminum. A worker clamps the first top plate in a jig. He sets the tower upside down on the top plate. The jig holds the tower in position as he first tack welds the assembly and then does full seam welds. After clamping side gussets to the tower, he turns it right side up and inserts the bottom tabs in a base plate to position it for assembly. He confirms that it stands at 90 degrees using an angle ruler. He welds this radar equipment tower to the base. He then sets the tower on its side to measure locations for tack welds and marks them. After the tack welds, he makes larger stitch welds intermittently to secure the gussets to the tower. He installs a gusset arm or bracket partway up the radar tower. Using a metal puck as a guide, he centers another top plate on the gusset arm. He clamps it to the gusset arm and also measures its placement to verify that it's properly centered. He welds it to the arm. He removes the puck and installs another mounting arm at the base, one that extends further. A computerized drill cuts bolt holes in a radar mounting plate. Radar bolting patterns vary, so it configures them to match up with a specific radar system. Once the bolt holes have been laid out, the drill carves the perimeter of the plate, taking it from square to round. The circular profile will match the base of the satellite radar system. In a process known as countersinking, he machines the rims of the bolt holes to a graduated profile. This will result in stronger connections to the mounting platform and the radar system. With a special deburring tool, he removes sharp edges left by the countersinking process. He smooths the outer edges of the mounting plate using a hand sander. The mounting plate then takes a tumble in a tub of vibrating ceramic stones mixed with water. The friction removes any lingering imperfections and sharp edges. The next worker cuts wings for an accessory extension. The accessories it could hold include a radio or GPS antenna or deck lights. The parts are hollow in order to house wiring. The wings will be assembled to a center trunk. But first, they cap one end of each wing. This will contain wiring snaked through from holes in the sides of the trunk. He welds a wing to each side of the trunk. And this completes the accessory extension structure. Next up is an arm for a navigation light. A hydraulic press bends the arm to the desired curvature. A measuring tool indicates the angle of the bend. He drills a hole for the installation of the light. After a powder coat finish has been applied to all the parts, everything is ship-shape and ready for final assembly on the boat. By supporting critical navigational equipment, this boat radar mount will ensure that when visibility is low, the boater can still get his or her bearings.